So this presentation is going to outline the technology on how to control your universal robot using a smart vision sensor. So the technology enables the easy use of universal robots in this instance with a smart vision sensor for vision guided robot applications. It's myself and where I'm based. So let's get into the content. So in the Baumer world, the VeriSense is our family of smart vision sensors, and the content of the presentation will be an outline of robotics and universal robots themselves, an integration overview of the smart camera, also what are UR caps, also the really clever part of the technology is this Baumer Smart Grid. Of course, we'll go through the conclusion of the setup and also go through some working steps in this presentation. And finally, when we talk about our smart cameras, what models are we talking about? And of course, a summary to end the presentation. So, classic robots without image processing really is the use of set positions where the robot is instructed to go, and in the universal robots technology these are called waypoints, and they are taught in to robots to approach with different types of movement, whether it be, for example, linear movements, where they do specific tasks, picking up, dropping off, all these types of things. So these positions are fixed and not flexible and programmed in to the robot. Now, if you are to use applications where you wish to use image processing, this means you're able to see objects in order to grab them, and even where they are freely placed, so in a tub, for example, where they may be stacked on top of each other or randomly placed. The vision sensor in this case will be able to identify the part to be picked and or dropped off into an area that needs to be recognized. So the smart camera provides new image-based waypoints with data that can be supplemented with a fixed offset, and I'll explain that later on with a working example. So this opens up the possibilities of what you can do with your robot, so vision guided robotics in fact. So testing for free space for the gripper, object overlay, free storage space, identification of objects for sorting and picking, and of course quality control, so that you're only picking up good parts, rejecting other parts, and of course different positions in the space. So why pick universal robots? So we pick this as an example because in the cobot market, the world market leader is universal robots, only robot arms of course in this case, but they've become very popular due to the ease of setup and programming, and the models that we talk about working with are the UR3E, 5E, 10E and 16E, and their motto is anyone can automate. So UR Plus certified accessories, the smart camera that you see here and the bracketry etc are all UR Plus certified accessories. The software integration via any of these accessories is called UR caps, or achieved via UR caps, which are basically applications, a bit like a smartphone applications, where you add it on to the main programming tool. So let's move on to the integration. So there are three main categories that you have to take care of in the integration, of course. Number one, mechanical, getting it mounted correctly and where you want to mount it. The electrical integration, obviously what wires do you need and how do you wire it up. The software integration, how simple it is to program the VariSense or smart camera. And of course, this all revolves around the pick and place coordinate alignment of how the universal robot will communicate with the smart camera. So there's two types of mechanical integration, and depending on how you wish to use your smart camera. There's dynamic, where you're fitted directly to the robot arm, at the end of the arm. So the smart camera is carried by the universal robot, and this of course allows you to look over larger areas, move to coordinates or waypoints that you want to look for something, identify it correctly, and move it to a certain area far away but still in reach of the robot, and see where you want to drop things off. So some really good benefits there, and the mounting looks like so for the universal robot. So the downside of course is increased base requirement around the gripper, and the load capacity is decreased because you're using the weight of the smart camera as well. And of course you've got to allow for movement where the wires do not get tangled, which is very straightforward but still a bit of a downside. And then of course there's fixed mounting mechanical integration, and that's above the universal robot, so you're looking over an area where the robot is working and moving in, and you're able to see everything that's in the field of view of the camera, even the robot arm when it's moving towards pieces. So of course this is easier to install, less weight and size at the actual universal robot itself, and the degree of freedom of the universal robot is higher. The downside is the robot arm can be in the image acquisition path, so the actual arm can be in the way of what you're trying to look for, or the area that you want to drop something off. So you may need to move the robot arm out of the way in the program to make sure that it can see the whole area that needs to be worked in. And of course these are just standard brackets that are required to mount over the robot itself. So moving on to the electrical integration, you can see the VariSense, whether it's mounted directly to the robot itself or above the area. You've got the pendant here, and you've got a Ethernet switch, and you've got a temporary PC or laptop required to go into that same switch. So the camera goes into Ethernet switch, the robot controller with pendant goes into the Ethernet switch, and the temporary PC goes into there. Once you've done that, you've got communication set up for all, and you can set up the software and everything else to get the program working. So the software integration for the universal robot is, like previously mentioned, similar to a smartphone with applications or apps. So the terminology used by universal robots is UR-CAPs. The VariSense has UR-CAPs developed to enable you to integrate the smart camera as simply as easy as possible. There are only 2 node commands during UR programming, and the extension of a UR with a smart camera and UR-CAP are certified by universal robots as official UR plus accessories. So this is really talking about the simplicity of the technology to be able to integrate a smart camera. So when you look at the software, within the VariSense software, you'll see under the tab robotics you have a simple drop down of universal robots. You just make that selection, and that allows you to access all the tools within the smart camera for checking features, to provide object positions, etc. to the universal robot. And importantly, the software, the VeriSense software, hands over the data or the information to the universal robot via the software in the data monitor, so directly out to the robot in a understandable format for the universal robot. Now, the golden piece of the technology really is the calibration, because this takes the longest for any vision-based system, really, and the key part of why it's made easier for a vision sensor. So, irrespective of, say, cost and all these sorts of things, the biggest bugbear for vision in robotics is the calibration and setup for changing real live coordinates or measurements from pixels, and also making sure you're correcting for distortion and all these types of things. And it's a real challenging part of the job. So this little tool here, the smart grid, is the main bit of technology over the smart camera, really, that needs to be talked about. So to summarize, what you need for a fully set up integrated smart vision solution is the smart camera mounted to the robot arm itself, the UR caps and the bracket enable mechanical and software integration, and the smart grid here enables all the automatic coordinate alignment in pick and place applications. So within the 5 points, you're able to get a full system integrated together. So let's move on to the UR cap. So software integration of the VeriSense with the UR cap is part of the controls. So the installation and the programming of the 2 additional nodes allow user-friendly, flexible integration from the smart camera to the robot itself. And the way the installation takes place, of course, is the preparation and guideline, the actual setup itself, and then the coordinate alignment. This is all integrated into the actual UR cap itself. So it's just a simple download and selection, and it guides you through those steps on how to do it. And this is kind of what it looks like on the universal robot pendant itself, and it talks you through the steps and goes through step by step on how to do it. So once you've got the smart grid in place, you'll see the smart grid there. You select the model of smart camera that you have, connect, and off and away. And using the smart grid, you can do the coordinate alignment in an automatic or semi-automatic manner very easily. And away into the programming side of the VeriSense itself, or the smart camera, where you're able to tell the robot what you want to do for in terms of job execution, which waypoints you want to move to, and what you want to do at those waypoints. And also we have a template for pick and place applications, so you don't have to write this from scratch itself. And this is kind of what it looks like on the universal robot pendant, and this is a pick and place program. So from the template, you'll see move to waypoint, pick something up, move to the position where you've picked and grabbed, take it over, and then drop the piece down. So you can just select this from the template and then make amendments to it if you wish, or you can write it from scratch. And there you see all the different categories when you click into parts of the node and waypoints of the nodes, what you want to do and what speed you want to move at, and all these types of things. All the variables you're able to change from the template itself. So, like I said, within the UR cap, we have a template set out for pick and place applications, which makes the job even easier, and you can use for both additional nodes of job execution and the waypoint as well. And we also support UR scripting of the programming. So if you're very familiar with universal robots, UR also offer the possibility of an own script programming for data exchange with accessories. Baumer recommends and supports UR Plus certified communication using this UR cap. So this is a bit of an example of what it may look like. So I mentioned before, what are the real big challenges of using any type of image-based system for controlling a robot. Whether you use a vision system or a vision sensor, these are the challenges you have to get around: is distortion of the image, how to deal with any distortion of the image, and how do you counteract that or deal with it. World coordinates is image processing. Doesn't matter which technology of image processing you use, you measure in pixels to start off with, and how do you get those to work in millimeters or inches or whatever you use as the world coordinates on the universal robot. And then of course Z calibration is a big issue as well. So vision sensors work in 2D and robots move in 3D. So how do we know how far away we are out in Z calibration without setting it up to be able to deal with that? And then of course is coordinate alignment, is with rotation of the robot end arm effector itself. How do you know, even when you're in the right place, whether the rotation is correct? So a coordinate alignment is also very important as well, and it's got to be synced up with the robot itself. So like I said, the technology that really supports this whole setup and use of a smart camera, rather than needing a full-blown vision system with lots of programming, making life a little bit tricky and a little bit more time consuming, is this innovative calibration tool. And it addresses all those challenges, and it really is essential for pick and place type applications. So the four functions of this smart grid are this chessboard pattern for automatic teaching of real-time distortion correction, and VariSense read scaling and position for transfer to world coordinates. So those are the first two topics I wish to talk to you about with regards to the smart grid. And distortion correction, so this is an example of distortion. So you have these nice squares, but when you look at it at the camera, you may get this sort of bowing of the edges. So it's very common with lenses or inclined mounting positions, and all you have to do is make sure that you put the smart grid under the camera, and if you just press calibrate, the VariSense understands the distorted image and makes the correction for it internally, enabling you to give the highest accuracy of dimensional checks and give you the robot coordinates very easily, because it knows this calibrated chessboard design. And also within that, we know the size of the squares and the correlation of the squares to each other. So where the camera is mounted, these pixels are set up as they are as the field of view, and we can then do a direct conversion from pixels to the units required, because we know the size of each of those squares. Again, all you have to do is press the calibrate button and you'll get that done. So after teaching with the smart grid, the VariSense knows, or the smart camera knows, the reference point, the direction of the coordinate system, and also the unit, millimeters, etc. So the third function of the smart grid is it supports Z calibration. So Z calibration is of course the approaching or furthering away of the camera or arm from the reference position, and know the size of the square at those at certain distances. We know where we are in terms of tilt, and also the size of each of the squares in comparison to the distance that you are away from the smart grid itself. So it's learning, it's teaching the robot the position in the room, basically, of where the camera is in relation to the smart grid. So a typical example of using the application for pick and place is if you are to mount the smart camera looking over this area. This is the object we have here. This is our Z characteristic here, the dimension there. We know X and Y generally. If we are to pick this object up, we want the grippers to touch here. You can see where we marked out the point of the gripper. We must put the smart grid within the offset, within a reasonable offset of where you want the gripper to land versus the reference level. So we wouldn't put the smart grid at the bottom, we'd put it near where the object is to be picked. So here we go. We've got our offset of the actual robot arm itself. We have to take into account the thickness of the smart grid itself, the object, and also the reference level. Now if we note all these dimensions down, 10 mil, 138 mil, 135 mil, the thickness of the smart grid 3 mil, and the reference level of 0, which is the bottom of where the object finishes, we're able to do the calibration within the application suite. So we input these figures into there, so 138 mil there, 135 mil here for the use of the Z correction, the 10 mil offset that we had, and also the 138 mil distance to the reference level. So these are all parameters that are within the robot pendant itself when setting up the coordinate alignment, and also within the VariSense software which you're communicating through the pendant itself. And then the final part of the smart grid is also that it supports the automatic coordinate alignment for the VariSense for pick and place applications. So you see this sort of translation here where this 90-degree angle matches the 90-degree angle of where the camera is set. If there is any rotation, we know because of the coordinate alignment, and with the smart grid we know what angle the square should be on that chessboard versus the camera position itself. So it's semi-automatic. You put in a few figures into the software and into the pendant. Allows you to use a smart grid to learn the coordinates that it sees on the smart grid, so the universal robot knows its position. The XY is relative to movement from the translation rotation because of that calibration, and we know the translation from rotation because of this as well. Now this makes the job super simple, because within a few adding a few numbers and just pressing the calibration button, you've saved yourself from manually setting up waypoint home positions, which can take up to an hour, hour and a half to do this type of calibration, whereas it can be done within 5 minutes using this clever bit of technology. And so you can see here what it looks like on the pendant itself, the semi-automatic coordinate alignment. You just click finish on that once it's, and there you are. So of course there's a couple of ways to mount the smart grid, and you only need it for this during the setup process. Of course there's the dynamic and static way of doing it on the actual gripper itself or on the base of the robot itself. And you just select here whether you want it dynamic or static, depending on where you've put the smart grid itself. So to conclude, the smart grid has some functions, and that's really the technology I wanted to talk about. Distortion correction, conversion to real world coordinates, Z calibration, and coordinate alignment, and what you'd need them for as well, what type of applications there, and how and where it's done. So lots of benefits to talk about with the smart grid, and that's really the clever bit of technology I wanted to talk about. And it helps smart cameras to do the easy setup for easy and the majority of simple pick and place applications. Of course, there is a big place for full-blown vision systems within robot control or vision guided robotics, and of course the cost is much higher for those sort of things. But when there is the need where you need the higher precision, high megapixel count, and also looking for very small and precise defects in or differences between products, that's where it's needed. But for the majority of applications, a simple smart camera can control your universal robot. So yeah, going through the summary again, from the VariSense point of view or the smart camera point of view, mounting and focusing can be done from the camera itself very quickly. The image distortion correction is done via the smart grid, and then you activate the universal robot into communication for the UR via simple selection on the camera software. The installation from the robot side is just by using the UR cap. All the information is already there. You just put in a few figures and the job you wish it to do in a way. So when we talk about smart cameras for us, it's our 900 series within the VariSense family that can use all these functions, and there are C-mount versions of the camera, and also fixed lens type cameras, white light and infrared type illumination, depending on the target, depending on the application that you have. So compatibility with these models here and the VariSense camera models that we have here. Of course, there's accessories required for this type of technology. The smart grid, of course, how to mount it, the camera itself, all this, of course, the adapters and all these types of things that are required, and of course cables depending on the length required, 2 meters, 5 meters, 10 meters, etc., etc. And there are actually a couple of size versions of the smart grid available depending on the size required. And also there's a ready to use PDF that can be easily downloaded and printed to be used for the setup of the camera itself. In summary, the VariSense or smart cameras that control universal robots have made life easier than before. You don't need a full-blown vision system to do vision guided robotics. You can do it with a simple vision sensors with everything on board, no extra controller, etc., etc. UR cap is a user-friendly interface for the robot controller. Makes the installation time drastically reduced and also a lot easier. Only 2 additional nodes, UR commands that is, that guaranteed the fast implementation of UR applications. And the smart grid, the real technology that's the shining light in this, allows you to teach image distortion, correction, Z calibration, and also automatic coordinate matching between the varisense and the robot itself, reducing setup time to minutes, whereas it could have taken an hour plus before, with lots of manual handling and movement of the UR arm to different points on the reference area. So thank you for listening, and of course if you've got questions or want to discuss further, please get in contact. Thank you.